Good morning, good afternoon, good evening. We are back and we are better than ever before. Today we are talking about the angle between two lines as they relate to equations of lines in vector form or parametric form or even Cartesian form. Before, when we were talking about the angle between two vectors, we derived a nice neat formula. Cosine theta equals b1 dot b2 over mag 1 times mag b2. And it was very simple because if you have an angle between two vectors, you could always have it had a vertex to look at. Or vertex from which the angle was formed. So the angle could be acute or it could be obtuse. So this formula worked great. But when we talk about the angle between two lines, we are always going to talk about the acute angle. If you have two lines, they're either going to be that intersect, they're either going to form an obtuse angle and a acute angle, or they're going to form right angles. Okay? And in that case, the dot product will be 0. But here, whenever we have the intersection of two lines, we are always going to be talking about the acute angle. So that means, if you recall, if it's an acute angle, that we can cosine is positive for all acute angles on our unit circle. Remember, that's going to be in the first quadrant. That's where all of our acute angles occur, right? And here cosine is positive. So we only want the positive value for cosine theta. And in order to have that, we have to have these absolute value signs over the dot product, because the dot product could be positive or it could be negative. Okay, so we don't have that formula on our formula sheet, but I mean we kind of do, because we have the oops, wrong one. We have the formula for the angle between two vectors right here. We just have to remember to add the absolute value so we get the acute angle. Okay? And of course these are the directional vectors. We already knew that. So once you have that understanding, this is really pretty simple. Okay, find the angles between these two lines, and here we are in, let's see, well, we're really in vector form because we can rewrite L1 like this. XY is equal to, let's see, 2, -1. I got the 2 from here and the -1 from here, plus t times -3, and then here would be 1. Okay, and then L2, same thing, xy would be equal to, let's see, 1, -4, our known point, plus t. I'm sorry, these are in parametric form, not Cartesian form. Oop, it's not t. Bad, Mr. B. So that's going to be s. Remember, you can't use the same variable for your parameter if you have two different vector equations here. Okay, so this is going to be s times 2, 3. Okay. So remember, the formula is cosine theta is equal to the absolute value of b1 dot b2 over the magnitude of b1 times the magnitude of b2. Okay, and these should have vectors. And remember, b is our directional vector. Well, here's our b1 and here is our b2. So we're looking for the angle. So this is just going to be theta. I don't know why I can never draw circles when I'm doing these videos. Theta is equal to the arc cosine of the absolute value of b1 dot b2. So that's going to be, let's see, -3 times 1 is -6. 1 times 3 is 3. Over the magnitude of b1. So let's see, the magnitude of b1 would be the square root of 10, -3 squared plus 1 squared. and the magnitude of B2 would be 2 to 4 plus 9 root 13. And then you just crank that on your calculator and you get, if you're in degrees, you get 74.7 degrees. If you're in radians, you get 1.30 radians. Either one is fine. They don't specify. Actually, always either one is okay as long as they don't specify. But you generally, if you have a problem that's starting with degrees, you should end at degrees. If it's starting with radians, your answer should be in radians. Okay, next problem, or next example. If I have two lines R1 and R2, okay, if they're parallel, then the direction, we already know this, the directional vectors are multiples of one another. We already know that for some scalar k, for some real number. In other words, if I can take the directional vector v and multiply it by some number, multiply the vector b2 by some number k and get b1, then they're parallel. They're parallel vectors. And if these lines are perpendicular, then their directional, the dot product of their directional vector is going to be equal 0, and we say that the lines are perpendicular. So find the angle between these lines. Okay, so I have R1 here, R2 here, and this is just a cautionary tale to check the directional vectors. In this case, they are exactly the same. It could even be, so you know that R1 is parallel to R2, which means that the angle between them is 0 degrees. There is no angle between them. It's 0 degrees. Now this could also have been a multiple of this, like it could have been, let's see, -6, 2, -4, multiplying by 2, or it could have been something like this. I mean, there's an infinite number of possibilities, like -1, no, let's do -3/2, 1/2, and -1. What did I do? Well, if I take this times 2, then I get this, or this times 1/2, then I get this. At any rate, if the lines are parallel, the angle between them is 0 degrees. If their dot product was 0, you should check that out, or you will do it using the formula, then you know that they are perpendicular and the angle between them is 90 degrees. Okay. Last example, find the measure of the acute angle between the lines 2x plus y equals 5 and 3x minus 2y equals 8. Now we're totally in Cartesian form. So let's take a look at 2x plus y equals 5. If I put that in y equals mx plus b form, I get y equals -2x plus 5. And if I put this in y equals mx plus b form, -2y equals -3x plus 8, solving for y equals 3/2 x minus 4. Okay, so here the slope is equal to -2 over 1. Okay, well, we can convert that to a directional vector, which I will call b1. Okay, b sub 1. Okay, now remember, slope is change in y over change in x. And the components of a vector, or I can think of this as vertical change over horizontal change. And remember, a directional vector, or any vector, I'm sorry, is horizontal and then vertical. So this directional vector would be 1, -2. And so for b sub 2, using the same idea, this vector would be 2, 3. Okay? Horizontal, vertical. And with slope, it's vertical over horizontal. Well, once you have that, we are in business. So we just use our nice little formula, absolute value of the dot product. So that's going to be 1 times 2, excuse me, is 2. Let's see, -6 over, let's see, magnitude of B1 is √5 times magnitude of B2, 9 and 4 √13. So that's going to be equal to 4, or cos -1, I should say, of 4 over, let's see, I'm just going to leave that because I have my calculator. Y multiply 13 times 5, I get 65, no big deal, which is approximately equal to 60.3 degrees. Easy peasy pumpkin pie. That is all I have. Becker is out. See you next time.